Hey friends, Vincent here. Welcome to Fearless in Rust, where we make Rust clean and simple. Let's get into it. Today, we are stepping into the real world of cryptography with AES, the Advanced Encryption Standard. AES is not just another cipher. It is the global standard for symmetric encryption. It's used everywhere: TLS, SSH, disk encryption, mobile apps, and even government systems. If data needs to be protected, chances are AES is involved. Let's start with a big picture. AES was designed by two Belgian cryptographers, Vincent Riesman and Joan Damon. It was selected in 2001 by NEST to replace DES, which had become insecure. AES works on fixed size blocks of 128 bits and supports three key sizes: 128, 192, and 256 bits. And here's something important. AES is built as a substitution permutation network, exactly what we implemented in the previous video. But instead of a toy example, AES runs multiple rounds, 10, 12, or 14, depending on the key size. Each round applies carefully designed substitutions, permutation, and key mixing, optimized for both security and performance. Now, here's the key difference between learning crypto and using crypto in production. You should never implement AES yourself. Not because it's impossible, but because it's incredibly easy to get wrong. In production, you always rely on well-tested libraries and, when possible, hardware-accelerated AES NI. So, in this video, instead of re-implementing AES, we will use Rust crates to do it correctly. We will use two crates, AES for the cipher itself and CBC for the block mode, how blocks are chained together during encryption. And we'll implement AES 128 in CBC mode with picky CS7 padding. This is the way we fill the last block. Okay, let's jump into Rust. First, we import what we need. So, what do we need? First, we need the AES 128. Then, for the CBC mode, we will use the block padding, PKCS7. Then we need also from CBC cipher, let's say, okay, we have a block decrypt. Oops, block decrypt mute, and the block encrypt mute, and also the key initialization vector. Then lastly, we also need the CBC cipher, and we need the encryptor and the decryptor. Encryptor, and decryptor. Just put my keyboard in the proper way. Okay. I don't need at that point cipher. Okay, I cannot write this directly. Okay, now we define three important things: the key, the initialization vector, and the plain text. So the key, this is the secret that locks and unlocks the data. And the initialization vector, this is the randomness to make each encryption unique. So let's start with the key. Let's say very secret key. Then the initialization vector. Unique. and the plain text. Let's say attack it down. Okay, now AES requires fixed size blocks, so we need to prepare a buffer. So let's create a buffer. At this point we're gonna take the text, switch to vector. Oh yeah, because I forgot here the B. It doesn't give to me the toVector function. Okay, now let's save the length of this buffer. And now let's resize the buffer with the new length. So let's say pos plus 16. Okay, at that point, we resize to make room for padding because AES only accepts full 16-byte blocks. And for the second parameters, we use 0u8 like this. Why? Because this is just a temporary filler. It doesn't matter because paging replaces it. Okay, just semicolon. Okay, now we create the encryptor. Set up the AES with a key and initialization vector to perform encryption. So the encryptor. So this is AES 128. And let's use the new function. So we have the key and we have the initialization vector. Just use the into with the into function. Take from both. Take, that's all. Okay, now we have to perform the encryption with padding. So let's declare a variable for the encrypted method and let's use the encryptor. At that point, let's use the encrypt padding mode. Let's give it a reference of mutable buffer and the length take this way. Okay, and now let's just print the result. Take in exo. So ciphertext take x right here. Okay, and here let's encode the ciphertext variable. Okay, now let's print the result. Yeah, you see, the key here is 15 bytes and now 16. That's why. Oh yeah, I forgot here my expect. Oops. Let's say encryption fair. Up that way. Okay, now let's just encrypt. Okay, I think it should be okay. Yeah, I know. I forgot the type annotation at that point. There is PKCS7. Okay, great. Now let's run sample so 00 coding AES. Okay, let's see. We have this ciphertext. Okay, now let's decrypt. So let's create the decryptor. So here, in the same way, we have decryptor at AES 127 new. Okay, then here let's take the same. So key and initialization vector. Just that way is there. Okay. Now let's create ciphertext again. To vec. And let's decrypt. So at that point is the same. Let's use the decryptor. Here that will be decrypt padded mute. Always the same, so a mutable reference to the ciphertext that time. And we expect deck. Let's just a message. Fair. Okay, and let's print the decrypted message. That time let's use on text. Later. Tac. Donc, so at that point, let's use string from, let's say, from UTF-8 lossy. So why to use this function? Because this is to safely print decrypted bytes without risking a crash. So let's pass decrypted. Yep. Okay. Tac. At that point also, I must annotate the type. So PKCS7. Okay, I think we're good to go. Okay, and here you see we'll find the original message right here and right here. So now, this is where things get serious. Using AES correctly is not just about coding a function. There are rules you must respect. First, never reuse the same key and initialization vector together. Doing that breaks security. Second, never use ECB mode. ECB, for electronic codebook, encrypts block independently and leak patterns, so never use it. And third, CBC mode is okay, but today you should prefer authenticated encryption modes like AES-GCM, because encryption alone is not enough. You also need integrity. So let's zoom out for a second. AES is fast, secure, and hardware accelerated on most modern CPUs. That's why it scales from embedded systems all the way to high throughput servers. And under the hood, it's still the same idea you already learned: confusion and diffusion through a substitution permutation network. So here's what you should take away. AES is the modern standard for symmetric encryption. You don't implement it, you just use it. And using it correctly is just as important as understanding how it works. In this video, you've seen how to integrate AES in real Rust code, using proper libraries and safe patterns. Thanks for your time, see you on the next one.